so welcome back to the second part of the video on BJTs. In this video, I'm going to talk about the currents and the voltages of a BJT. Okay, so you need to know that a BJT works only when there's current going into the base. All right, so it only works if there is a current going into the base. So since it's a current going into the base, we shall call this the base current, okay, IB. All right, and if I have a base current in, that means it kind of opens up this route for the current to flow, and that's why we say sometimes, not sometimes, BJTs do work as switches. So the moment I have a current going in, it kind of switches on this route to allow current to flow here. So what you need to know, I have current flowing into the base. It allows current to flow into the collector called IB, and the current will flow through here and gives me eventually the current flowing through the emitter called the emitter current. Now, this base current actually goes through here. Okay, this base current actually goes through here. So therefore, the emitter current is made up of the collector current flowing through here, as well as the base current flowing through here. So this emitter current is made up of two currents, the one flowing down, IC, and from the base flowing through as well. So plus IB. Okay, so this is the first equation that you must know. The second thing that you must know about the current is that all I need is a small little base current. I just need a small little base current to flow through the base, and that's it. Boom, it's good enough to open the floodgates for the collector current to flow. Okay, so the second piece of information you need to know is that a small base current is enough to open up to a big collector flowing down, kind of like opening a switch or opening a gate. So activate this by putting in a small base current, boom, a big collector current flows down here. Okay, so how big? So this is the second information you need to know. The collector current is beta times the base current. So beta is like the multiplier. Okay, so for different BJTs, you will have different betas. Yeah, so this beta, think of it as like a multiplier. This fella can multiply the current of the base into so many times. How many times? Depends on the beta. Typically 40 to 100, depends on the BJT that you are using. Okay, and how do we find this value of the beta? We come to the data sheet. Right, so this is in your textbook. If you look for the data sheet all the way down here, so this is your beta. Now over here in the data sheet is written as HFE, but it's the same thing as beta. So depending on the conditions, okay, this DC current gain called the beta, the DC current gain for this particular BJT, the maximum is 300, but it ranges from 40 to 100 all the way to 300, depending on the conditions that it is operating in. Okay, so how many times the base current depends on the beta value. So you need to know two pieces of information. You need to know this information, that IB, the base current, is actually beta times the DC current gain, and that makes up the collector current. Okay, so a small base current gives me a big collector current. How big? Beta times. Next piece of information, you need to know that the emitter current is made up of the base and the collector, because they both flow down to come out through here. Okay, so this is talking about the current. Now I want to talk a little bit about the voltage next. Okay, so this is exactly the same diagram, but now I want to talk about the voltage. Yeah. Now you have to know that the voltage here at the collector is called the VC, the collector voltage. The voltage at the base is called VB. I hope you're starting to see the pattern here. And the voltage or the potential at the emitter is called the VE, the emitter voltage. Okay, simple enough so far. Remember this. Next piece of information, you need to know that in order for me to go from the base to the emitter in terms of voltage, right, there is a voltage drop here. There is a voltage drop here called the VBE. So notice there is a voltage drop here. Remember this, there is a voltage drop here. There is also another voltage drop going from the collector all the way to the emitter, and this voltage drop is called the VCE. Okay, so for the voltage, it's just quite simple. You just need to remember what's the VC, VB, VE. That's the voltage, the potential at the collector, base, emitter. And the second thing you need to know is that there is a voltage drop across the base and the emitter called the VBE, and there's a voltage drop across the collector and the emitter called the VCE. If you're wondering, whoa, why is there a voltage drop? How does this voltage drop happen? Like, what's going on here? Okay, I could explain everything to you, but I suspect that will confuse you even more. So right now, all you need to know is this 1, 2, 3, the potential, the voltages at the 3 points. The second thing you need to know, there is a voltage drop between the base and the emitter, and the collector and the emitter. Okay, so remember these two about the voltage. And coming back to the current, remember these two information about the current. So that's all you need to know about the current and the voltage. So I'm going to stop here. I want you to relook this video if you need to. Remember the two pieces of information about the current and the two pieces of information about the voltages that I've been saying. Okay? So I'm going to stop this video. I'm going to go on to a part 3 later on to talk about how BJTs work as a switch. Okay, so see you in part 3.